and a ray of light is incident upon this plane mirror.
Can't be in front of
It's
this.
gonna bounce back at the same angle.
Yes. There's some angle it's making. And so the outgoing ray is going to bounce off and make the same angle. Alright? That was basically the point of the first lab with the mirrors. It was trying to figure out, alright, if this is what light does when it hits a mirror, how do I figure out where these rays of light are going to be going?
Wait.
That's not really the best example. I kind of made it accidentally perpendicular. Right? Stuff like that.
Yeah.
Now, when we went on and talked about spherical mirrors and still even a bit about plane mirrors, what else were we worried about with mirrors? So, like, every mirror problem we did on the worksheets was involved doing what?
Finding the image.
Finding the image.
Oh, okay.
Yeah. Right? So, if we've got a plane mirror again, a red plane mirror this time apparently,
Christmas.
and we've got a green person,
Santa.
The Santa's red.
how do I find the top of this person's head? How do I find the image of the top of this person's head in the mirror?
You put a dot.
And that's that.
I put a dot. And what do I do with that dot?
You draw some rays.
I draw two rays. Whenever we want to locate one point, we draw two rays. That is true plane mirrors, true spherical mirrors, true with lenses. Always locate one point, draw two rays.
Yeah.
Interpretive robot dance.
Anyway, what two rays do I want to draw for a plane mirror? So I draw one that goes straight in. If it goes straight in, how does it go out?
Toward no, I lied.
Straight up.
Goes straight out.
Oh.
What other ray do I want to draw?
One
Any
going
ray.
Any other ray I could possibly imagine. So if I draw this ray that goes in this random direction, how does it go out?
In the random
It
direction.
goes out in the opposite of that random direction.
Yeah.
Basically. So these two rays that are going out, the one that's coming out here horizontally and here going down into the left, are they going to intersect?
No.
No.
No, so what do I have to do?
Bring it back.
I got to extend them backwards into the mirror. Bum, bum, bum. So then what happens now?
That's where the hair frost is right now.
This is the location of the image of this object. Alright?
When we have plane mirrors, whenever we drop it, it should be like if your left hand's up in a mirror, it looks like.
So like, if this is his left hand, right? It's closest to the mirror. On this side, the thing closest to the mirror will be his left hand.
Okay.
Alright? Even though it looks like, even like if it was person, if this is the left hand on this side, this is the left hand in the image. Because the image gets reflected in a different kind of reflection. It gets reflected in like the geometric, algebraic kind of sense instead of the I can see light, it's shining into my eyes, reflected. Alright, then we had spherical mirrors. And I don't have any string anywhere. Oh, hold on.
It's funny because it's actually a spherical mirror.
But it's funny because it's a spherical mirror in this plane, not in this plane.
Oh, yeah.
This actually would have been a better sphere. Alright, with a spherical mirror, if this side is shiny, is the mirror convex or concave?
Convex.
Convex. If this side of the mirror is shiny, is the mirror convex or concave?
Concave.
Concave. Is the focal length positive or negative if the mirror is convex?
It is
Positive. Positive.
Positive. Positive.
If it's convex?
Positive. Negative. Positive. I don't know. You're making me nervous.
I think it's positive.
If this is my mirror, because it's convex, my thing is over here.
Yes.
Where's the?
Oh,
where's
it's
the
on
focal
the
point?
virtual side.
The focal point, the center is somewhere over here. The focal point is somewhere over here. And it is on the virtual side of the mirror. It's
So
inside of the mirror.
Negative.
So F is less than 0 for a convex mirror. What about for a concave mirror?
It's more than 0.
Because like conversion and diversion doesn't work.
Alright. Yeah?
Yeah.
Yeah.
Do we remember what the rays are for spherical mirrors?
One.
Parallel and then to the focal point.
Yeah. So if I want to draw with this, if I want to locate, this guy's head, my first ray goes in parallel. And it comes out from the focal point. Alright? What does my second ray do?
Goes in toward the focal point.
Into the focal point. And then what?
Out parallel.
Out parallel. Is the red ray and the green ray are the red ray and the green ray going to intersect?
No.
So what do I have to do?
Extend them.
I have to extend them into the mirror. I actually think that we videotaped this review last year.
There's a video on Haiku.
There are a lot of videos.
I mean about this.
I think there's a video in my YouTube channel from last year about this. And so that's where the head is.
What is C
Oh,
again?
what?
C is what?
So it's a spherical mirror, that's the center of the sphere.
Okay.
Alright? Where's the focal point in terms of the center?
Half.
It's half the distance, right?
Yeah.
Yeah. The focal length is half the radius. The focal point is midway between the center and the mirror. Alright? It's always these two rays that we're drawing. These are always the two principal rays we want to draw. One that goes in parallel to the principal axis and will go out, somewhere either to or from a focal point. And one that goes in to or from a focal point and goes out parallel to the principal axis. We can draw it a lot of different ways. This one in parallel out through the far focal point, in parallel out from the near focal point, in parallel out from the focal point. We can also get ones that go in parallel out through the focal point. If it's a concave mirror, that's a totally legit ray.
Is that how you draw the rays?
Yeah. Be a very slapdash way to draw them, given that none of these lines are straight or in any way related to each other. But there are a whole bunch of variations on these, but it all comes down to parallel, F, F, parallel. No matter which type of mirror, no matter which type of lens. You just have to remember which
F.
and how it's always parallel, so that one's easy. Alright?
Okay.
Now, in addition to doing this with pictures, we also had equations to work with, right? Like this one for the spring force, and over here, the work done by a variable force in terms of the integral of f dot dx.
No. I don't make it.
That came up all the time when we were talking about lenses, right?
No. Because that's confusing and has too many variables.
So the one equation that we kept using again and again and again and again was this one.
Yes.
You understand?
And then we had these two ways to talk about the magnification. Right?
Yeah.
So all the math that we did comes down to messing with these equations again and again and again. Yeah?
Yes.
You gotta be very careful when we add fractions. Remember, 1 over x plus 1 over y does not equal 1 over x plus y. That is not true. For example, if I give you a half of a pizza, when you already have a half of a pizza, you do not have a quarter of a pizza. That is not true.
Okay.
Alright? It is a very tempting habit. It is a very dangerous habit because it is very much wrong. Okay? Other questions? Comments, concerns, queries, conundrums?
These are going on like YouTube.
I'll put them up.